Good morning and welcome to Algebra 1. This is Wednesday, April 29th. Today I'm just going to review what we went over yesterday, which was our introduction to quadratic equations and some of the vocabulary associated with the graph of a quadratic equation. So first quick example, if I gave you a parabola that looked like this, remember that they're called parabolas, P-A-R-A-B-O-L-A. Parabolas have a vertex. It's at the turning point. So here, that's my vertex. When the arrowheads point up, kind of like a smile, we call this opening up. So we say it opens up. And when the parabola opens up, the vertex is at the bottom of the parabola. So we call it a minimum, because the y value never gets lower than that point right there. We also read a parabola left to right. So as we come left to right, I know the arrow is pointing up like that. It doesn't mean we're reading it in that direction. So as we come down towards the vertex, this is decreasing towards the vertex. But as it moves away from the vertex to the right, it is now increasing. All right, so parabola, decreasing as it moves down from the left, increasing as it moves up to the right. The vertex, the turning point of the parabola, in an open up parabola is at the bottom, and we called it the minimum. A good example of what that might look like, here, just y equals x squared. We'll keep it basic. That's the basic parent function of a quadratic equation. Okay, how would we maybe, graph one? Well, that's what your IXL assignment was all about. It was graphing a parabola. So some of you might have had some problems. Some of you are trying it and doing fine. Some of you, and I've seen the IXL score grid, some of you haven't even touched it, which is fine. I said it wasn't due until Wednesday, end of day. So I'm going to give you an example, perhaps, of one that you might see. Let's say y equals 2x squared plus 1. All right, the order of operations is really important when you're trying to figure out the values in the t table. We said we make a t table. It's the x, y, little organization of coordinates. We said that right now we're looking at the basic x values, the inputs that make it easy to solve, -2, -1, 0, 1, and 2. You don't always have to use those numbers. Currently, they're the easiest because of the equations I'm giving you. They won't always be. We'll get there when we get there. When you plug in a -2, guys, y equals 2 times -2 squared plus 1. Please understand the order of operations is very important. So y equals 2 times -2 squared is -2 times -2, which is a positive 4. Plus 1. 2 times 4 is 8, plus 1 is 9. You have to either do it on paper or do it carefully with parentheses in the calculator to get these answers right. When you plug in a -1, y equals 2 times -1 squared plus 1. Again, the exponent happens first. Don't forget PEMDAS, parentheses, if there's work to do in parentheses. Exponent, if something's getting a power. Then multiply or divide, and then add or subtract. That's what PEMDAS stands for. So it's not 2 times -1, and I probably should have said that over here also. It's not 2 times -2. It's 2 times -1 squared. What is -1 squared? -1 times -1 is 1. So it's 2 times 1, which is 2. 2 plus 1 is 3. 0 is really easy. So I'm just going to point and tell you that if you plug in a 0 for x, 0 squared is 0. 0 times 2 is 0. 0 plus 1 is 1. But I'll show you the other two on paper here. So plug in the number 1 now. Y equals 2 times 1 squared plus 1. Again, it's 1 squared. It's not 2 times 1 and then square it. That's wrong. It's 1 squared, which is still 1. 2 times 1 is 2. 2 plus 1 is 3. And you'll notice that there's symmetry here because we've landed on the vertex and now we're turning around. Finally, plug in a 2. Y equals 2 times 2 squared plus 1. 2 squared is 4 plus 1. Please notice every time I do this, I keep them in parentheses. I'm never multiplying first. I'm squaring first. It's very important. Y equals 8 plus 1, which is 9. We have the coordinates. Now, I'm not going to worry too much about you graphing coordinates. I'm hoping at this point that's no longer the main issue. But here's a quick graph. I have to go some negative x, some positive x, but only positive y. So I'm only going to do what I have to do here. Okay. Negative 2, 9 is up here. Negative 1, 3 is over here. 0, 1 is over here. 1, 3, there you go, right there. And 2, 9 is up here. So we would sketch it, we draw the curve. I missed my point. We have our arrowheads and we're done. Okay? That's all there is to graphing it. The key here is that you plug in the numbers correctly and follow the correct order of operations. We would always have to square before we multiply. So one more example and then you're free to go back to your most favorite activity, IXL. Try this one. Y equals negative x squared minus 3. Negatives have always been an issue for us, but let's, again, just take it one step at a time. By the way, the IXL might give you different inputs than what I've been giving you. That's fine. If they gave you the inputs 3, 4, 5, 6, 7, just use them, plug them in, see what you get. But again, do it correctly and carefully. Parentheses are important. I'm plugging in the negative 2. The first thing I have to do is square the negative 2. So, negative 2 squared is negative 4 minus 3. Again, 4 was what you get when you have negative 2 squared, but there's a negative on the outside. Since there's a negative on the outside, it's negative 4 minus 3, which is negative 7. One step at a time. Plugging in the negative 1. It's negative 1 squared minus 3. So it's negative 1 squared is positive 1. Minus 3, so that's going to be negative 1 minus 3, which is negative 4. Okay, I'm going to do the same thing with the 0 I did last time, which is just talk it out. Negative 0 squared minus 3, well, 0 squared is 0, negative 0 is 0. Minus 3 gives me negative 3. I'm going to go to the 1 now. Y equals negative, parenthesis, 1 squared minus 3. 1 squared is still 1. So negative 1 is negative 1. Minus 3 gets me negative 4. And plugging in the positive 2, y equals negative 2 squared minus 3. Y equals negative 2 squared is 4 minus 3. Negative 4 minus 3 is, again, negative 7. Okay? We should have symmetry if we chose points that were symmetric to the vertex of the parabola. So I have my values. Again, you can pause the film, you can watch this, you can go through it, you can rewind. please understand the order of operations. We square the input first, then we would apply whatever came before it as a multiple, then we add or subtract whatever follows it, okay? And a quick graph of this as well, and I'll be done for the day. All right, I've got positive and negative x. I've also got all negative y. So I'm going to just make my grid kind of like this because I don't really need any positive y space. Just showing what I have to show right now. Negative 2, 7 is down here. Negative 2, negative 7, I should say. Negative 1, negative 4 is over here. 0, negative 3, right there. 1, negative 4 is over here, and 2, negative 7 is down here. Again, it's symmetric because it really should be. And I'm going to just do my curve, and there's my parabola. This one opened down, so its parabola has a vertex that's a maximum. It opens down for a very specific reason, and you could go back to the previous slide if you'd like to, rewind. It's got to do with that right there. When the equation begins with a negative, it's going to open down. We call that reflecting over the x-axis. When it opens down, it's because the equation was negative x squared. If it opens up, like a smile, it has a positive x squared value. Positive 2x squared, positive a half x squared, positive anything x squared, positive x squared. Okay? Now, all I'm asking you to do is continue working on the IXL BB.3 for 85% or better so that you can graph the parabolas. It's just like this. Just input your values carefully. Use parentheses if you have to. Use a calculator if you want to. You could even go to desmos.com, desmos.com, and you can use the functions there for graphing. It's going to be very helpful if you don't have a graphing calculator also. That's all for today. Please do the IXL. It's due tonight by the end of the day. And have a wonderful day.